In the meantime, I make one. What about the precision landing?
What about what, sorry?
The precision landing. So it is something you have a range in which you can land with respect to the
Yes, I mean, I think, again, it depends very much on a customer need, because we can add different systems to basically get the precision of landing that a customer, if you're landing in the middle of a mare and it's 10 kilometers flat, then there's no point spending the resources than if you need to land in a 100-meter circle. So the answer is yes, we can provide what's needed.
Okay, thank you.
Yeah, so question for Fabio. How are you going to distinguish between very small, short duration impact flashes and cosmic ray impacts, assuming that you have only one detector and you're operating in a very cosmic ray rich environment? Good. Okay.
All right. Can you hear me? So we have one camera with the beam splitter and two detectors, visible and near infrared. So we mark as detected when both, of course, have a.
Excellent. Thank you.
I guess it's a question for more than one person, but maybe Ben can answer this, because you alluded to the fact that in 2 years' time, there would be so many missions returning so much data on the back of it. Quicker missions can be put together. I mean, what would be your recommendation for universities? Because we need workforce, right? We need next generation ready in that time, and it takes time to train people to be ready. In your opinion, do you think there is sufficient workforce out there that can actually utilize it, the data at that cadence start to come in?
I think the answer is yes. I mean, if on the US side, we've seen the excellent PRISM instruments that have been selected. And you've seen, we saw today how that those are already taking advantage of being selected to grow the next generation workforce. And also, I think it's a bit like when ELS first started and we had a lot fewer people than this. Once we start to do things and fly and get the data, then that will naturally grow the workforce, because people hopefully will go into those science and engineering fields because they see that an interesting career that they can do.
Okay, thank you. I just hope that, while we are planning for all of that, we can also keep that in mind and universities pay attention to that.
Well, that's your job.
Thank you.
Yeah.
Hi, good afternoon to everybody. This is Alejandro in Spain. I have a question to answer Losa on the radio telescope mission. With regards to I'm pretty curious about the thermal management strategy you follow. Maybe if I understood well, you plan to operate all through the night, to have your receiver on through the night, and you basically rely on this large package of batteries and the self-heating of the batteries and certain degree of isolation. So after that, when the day comes, you have these large solar panels as well to recharge the batteries. So my question is, you count on the panels to be able to survive the night by their own without any thermal aspect, and how you account for degradation or in terms of functioning, for how long is this plan, how many diurnal nights, and so on.
Okay, so to repeat the question is how we deal with thermal and energy issues and solar panels, right? So the basic concept is basically as you described, right? So we land with the battery, which is kind of in the morning with battery, which is essentially flat. We charge the batteries during the day. We have about 7 kilowatt-hour battery, about 40 kilos. It's basically upscreened commercial battery. And we were specifically told, because it's Eclipse mission, no radioactive stuff. That's why we have to survive no battery. So then during night, you have this instrument that draws between 10 and 15 watts, depends exactly how you count. And this heat is then used to keep us warm, right? So during the lunar night, the ground is about 100 Kelvin, and inside the instrument will be around 0, right? 0 to 20, right? By the means of simply thermoinsulation. The battery is going to be drawn down a lot, much more than in typical missions during the night, so we nearly empty it. However, this is not so bad because we have these very slow cycles, right? We slowly recharge and slowly kind of lose charge. We have like one full cycle per month, right? So it's going to be the load battery is going to be very easy. Now, in terms of thermal during the day, things get very hot, and we, as I mentioned, we have this tube that kind of opens up. It's kind of it's like this it's this heat pipe that basically becomes conductive above a certain temperature, and this will just reject extra heat, right? And we have oversized both radiator. We have oversized the tube, and we have oversized the panels. So the panels have some issues about basically about 10. We can lose. We have about 20% margin on the panels due to degradation, right? Next thing is how will thermal panels survive the night without cracking? We spent a lot of time thinking about this. We had all kinds of concepts that will go in and out. At the end of the day, basically, we simply found this company that sells us the panels that were supposed to kind of they have special cover, and as long as they're on the sides of the thing, they should survive. Okay. Having said that, the tail thermal modeling, whether we will need to put some heat down, I mean, this is still in the process of being done, but it's one of the major technical challenges is basically identify the more difficult things of this engineering project.
Thank you again to all speakers.